Hey everyone, welcome back to MLWorks. In this video, we'll start with weights and biases tool. So we'll start off with setting up weights and biases locally, and then we'll start off with how to track an ML experiment in weights and biases. To get started, we have to create a virtual environment. So we'll create that, and then we'll create an account in weights and biases. So which are like very simple steps, and you just have to follow along. So first is Python 3-m v. So we have to create the virtual environment. So I have already created it. So I'll just switch to the virtual environment and then activate environment. So now when it comes to the package, you just have to install pip install weights and bias, and this will install all the dependencies and weights and bias package. Once you are done with that, you can go ahead and let me go here. So this is the website where you want to sign up for weights and bias, and this is the URL, and you have to submit a form where you have to give the username, mail ID and company name. And once you have submitted the form, you will be seeing a page where you will be having your API key. That page doesn't appear, you can click something like on the profile on this side, and at the API key you can go there and take your API key. So once that is done, then you are good to start with weights and biases. So what you have to do is, first let's jump here where we'll be starting with some dummy experiment for machine learning. So first import the packages, which is weights and bias and some package with related to mathematical calculation, right? So we'll use some package here, math and random. Once that is done, we'll be importing all these packages. Then you have to log into weights and bias. For that, you just have to do weights and bias.login, and it will ask you to enter an API key here at the top. Just have to copy the API key from here, from the platform, and paste it here, and you will be good to go. So I have already pasted it, so it is there. It is taking that from the older reference. Now comes the dummy training loop. So here comes, first we want to create a dummy config for our machine learning experiment. What is the project name? And then we have to kickstart the w weights and bias run with the init function. So with weights and bias.init, pass the project name and the configuration that you want to map to this experiment. So you pass that config here and run it as a run. And then inside this, you will be training your machine learning model. So since this is a dummy machine learning training loop, what we do is we just have 10 epochs. We randomly create an offset, and then we run through this 10 epochs and calculate the accuracy and loss. Now, while we are doing that, we are also doing something called as run.log, which is part of weights and bias, and it will log your metrics. So let me run this. So if you see, once it is running, you can see all the things that is happening. So here you have tracking run with this specific version of weights and bias. Run data is saved locally. So there is whatever that execution that has happened, it is stored locally as well. And the name of the run is unique-rain1, and this is the document. And view the project, you can go and click this URL and it will open that specific project. And if you want to go to that specific run, then you have to click this URL. So what I'll do, I won't click anything here. I just go here to show you what is happening. So here is the project, view all. So it will show one project, basic intro, which is the name which we gave to this specific experiment, basic intro. Now you will see there are two plots. One is loss and accuracy, because we just have two metrics that we are tracking. So here we have our metrics that is getting tracked. And this is a very simple example. Now what we'll do is, next we'll be looking into a PyTorch model. We'll train it and we'll see the tracking for validation loss, training loss, and how to create a report. So all we'll see that in the next cell. So this is the basic run history and run summary of this specific run what we have done. And what is happening is, once you are started executing this, it will start uploading your files, all the metrics that is getting generated, it will start uploading to weights and bias. So that's what is happening with this specific set of commands that has run here. Now comes how to track an ML experiment with using PyTorch. So what we have to do is dependency packages needs to be installed. For example, for this pillow for image, and then we are installing Torch CPU version, and we are installing both of them. And let me just comment that out because it's already installed. Now comes the part of data loading and then creating a model. So what we do is we import all the necessary packages that are required for downloading a data set, creating a transformation, and then creating a model. So first we check for data set, then we see whether we have CPU or GPU, and then we write a function for downloading a data set and creating a batch out of it, and that is basically a PyTorch data loader. And then we have a function for creating a model. So this will take in a parameter called dropout, which will be like, which if you are not aware of deep learning, this will drop out neurons from your neural network randomly. And in data loader, we take isTrain, or if it is or not isTrain, if it is false, then it is a testing data set, something like that. Batch size is something you keep it while you are trying to train, and slice is your subset of data set that you are creating. Now comes validation of the model. So what we do here is we load the model in evaluation mode, and then we start off with validation loss of 0.0, and then we, with inference torch.inference mode, we keep iterating through the validation data set and get the prediction result and start tabulating it. So if you see here, there is something called as log image table. So what it does is, this is a specific function. Okay, if I'm not wrong, if you go here, it's somewhere log image table. Okay, this is the one. So what it does is, if you see here, log image table, it will take images, predicted, labels, and outputs dot softmax dim is equal to 1. Okay, now what it will do is, it will try to predict for every image, and it will get the class and the corresponding probabilities. And those probability scores will kind of also be viewed in the this log image table, which is available in the platform of weights and bias. So let me run this first. So next, run this one. So the whole idea is to just view your prediction results along with the class probabilities. All those can be tracked here with the help of this function. So here you are specifically using W and B weights and bias dot table and corresponding columns. What is the score? This is probability score, and then we are iterating through those, again pushing from CPU, we are iterating through those values of images, prediction results, target, probability score, and then we are adding that to the table which we created earlier here. And then finally we are committing it with the help of weight and biases.init and as run. Now comes the point of weights and bias, where we are trying to train the model. So what we have to do is, as usual, you have to set your configuration that you want to post it into your weights and bias platform, and what is the project name. And with weights and bias.init, you will have project, you will pass the project and configuration detail, and you will be running it as a run. And inside that, what we do is we create a try catch loop, and finally we want to close the run. So in the try statement, what we have is, we take the configuration and then we take the data loader from the PyTorch one, train data loader and validation data loader, and then what we do is we number of steps per epoch that we want to calculate, and then we have to get a model which we already created from the earlier function, and then we have to define our cross entropy loss and then optimizer and the learning rate. Next comes the steps for training. So what we do is we iterate through the epochs and we start our training. Once we start the training, we'll be updating the weights, and then once we are updating the weights, we are also calculating the losses, either it is training loss or a validation loss. So all those things are happening in the back end. Okay, so if you see here, here we'll be calculating the loss and we are tracking it inside this specific dictionary. And here if you see, we'll be calculating validation loss again, then we are logging those metrics again here, and again we are also logging the metrics here. Once the training is done, okay, because this is outside the loop, so what we do is we save the model Okay, so what we are doing is, since it is inside the loop, we are checkpointing it. Okay, so we are checkpointing the model. So this will also be checkpointed in our weights and bias platform as well. So we have to, if you want to check the results or pull out specific checkpoint, you can take it from there. And then what we do is we epoch what is the corresponding for each epoch, what was the corresponding training loss, validation loss, and accuracy. And then we run the summary. Test accuracy is 0.8. So here some specific points that you have to remember is the set of commands that you have to use. One is run.log for logging the metrics. For logging the model, you have to use run.log model. And if you want to come out of the loop of this session, right, weights and bias session, you have to do something called as run.finish. If you don't give this one, if you are running it as this, right, with statement, you don't have to give this run.finish. It will automatically close. So we can skip this part also if required. So let me run this. I hope we have executed all the other statements. Let me show you this one, right? We have already executed this one. Okay, this is executed this one, but it was not called anywhere, I guess. So let me go to the project again and see. Yeah, we have PyTorch intro project is getting created. Now we have multiple. So this is from the previous experiment that we did. Okay, it is pulled those reports as well. Now let me see what is the name of this project, right? Pretty tree 1. Okay, let me refresh this one. So here the training is happening. What we are saying is epoch 1 training loss is 0.314, validation loss 0.39, accuracy 0.89. So then the accuracy is moved to 0.91, 0.92. The loss is getting reduced, and even the training loss is getting reduced on both the side. So the experiment name is the run name is pretty tree 1. So it should be here. Yeah. So this is the one. And you will notice we have this training loss that is getting captured, and as the number of steps are increasing, the training loss is decreasing. And this is the steps, and this is the epochs that is getting tracked. And this is the validation loss, where we have validation loss and accuracy. As the loss is decreasing, the accuracy is increasing. And there are system metrics that is getting captured while you are running this experiment. One is GPU fan, GPU power usage, and all those stuff. This is not important for now. The whole idea is to track the experiment, but you can also capture these details from your system and you can share it across the platform. Now, while this execution has happened, okay, so if you see here all these different URLs, it refers to the specific experiment that we are running here. Now, what we can do is, one thing that I wanted to show is the artifact. Here, if you see, you will see the artifact. These are the models, right? The model version 0, version 1, version 2, version 3. So these are different versions. Let me go back here, PyTorch intro, and here if you see, again I'll click this one. And what was the dropout, and this is the way we have given the name actually. So this is the artifacts. I'll go to the runs and then I'll click this run, and here I will create a new report, and this imports charts and everything. Okay, I want to select all this. I don't want systems, so I'll create a report here. Now you will see a report, and you can also share this report with anyone. Okay, so let me change the name of this report. PyTorch classifier report MNIST testing in weights and bias. So this is the report, and this is for one specific run that we have done. Now it contains all the information, and what you can do is you can either publish it, and I guess there is an option to download the report and you can send it across. Okay, that is one of the functionality provided by weights and bias. Now this is with respect to the report. Now let's talk about runs here. What we have, all the different runs that has happened. Okay, only one run we had done. So let me go ahead here and run again. Okay, we'll see what happens now. So while that is happening, let me go back to the projects, and we'll see here. Yeah, this one, explore libraries MLOps. So this is TOEIC paper 1. Okay, if I go back here, right, somewhere here, this is where we had this log image table. So if you see here, we created a table here which represented the images, labels, prediction. Okay, so if you see here, this is the image, prediction, target, and these are the labels we had. For 0mnest, the probability score was 0.281. Okay, and since this is the image is 7, the score for 7 is 0.99. And for image 1 containing the digit 1, the probability score is 0.98. So this is one way of managing or representing the prediction results. Now again, you can turn this into a new report and share it across, and that's up to you. Yeah. Now, is there anything else that I'm missing out? So these are the different things that we had talked about. Let me go back here. Now, few more things, right? If I want to access the report, it will be available here. If you want, if once you make the public report, you will be able to see the reports here. And if you want to delete any experiment, you can just go here and delete it or rename the experiment, and that's it. So we have executed it second time. Okay, so let me go back here, and under PyTorch intro, I will have another run which is called Sweet Darkness 2. Now under this, you will have again the same set of metrics which we have captured, and then we again have our system metrics, which contains GPU based metrics, network traffic, GPU utilization, disk utilization, all the other metrics which you can share with other team members. In terms of log, yeah, so this is the log. So what it shows is whatever the experiment that we do here, it is capturing all this log and sharing it here. And is there any files? Yeah. So with respect to the experiment, these are the files that are getting generated. So we can get these details here. And if we go to requirements.txt, yeah. So this is the environment setup that we were using for this experiment to run. So we got that. If you see here, Torch is equal to CPU because we are using CPU version of Torch. So it has also captured the environment details and stored it here. If you want to just repeat this experiment somewhere else, you can just go ahead and use all these artifacts and then kickstart your prediction or inference also. And this is the again history of the models that we have stored here. So yes, this is how you can get started with weights and bias, and we'll be talking about much more in detail in the next video regarding this tool. Thank you for watching.